Okay, Algebra 2 class, I'm going to do all the problems on your study sheet so that you're super prepared for this test. This is totally an act of love from my heart because this will take me at least an hour and a half of my life to do this. So anyway, let's get started. I really want you to understand how to do these particular problems for the test, and hopefully if things haven't clicked for you yet, this will be the time that they click. Also, if you really get a problem, you can fast forward through the video, but most of you probably want to watch the whole thing. This will take a while. You can watch it in 2 different parts or whatever. I'm not sure exactly how long it's going to take. So anyway, let's get started. 26, number 1, and actually I think it is really, 26, number 1. Okay, I didn't write this problem down, but we did this one in class, but not everybody got it. The Silver Arrow made the trip in 20 hours. The Orange Blossom Special made the same trip in 8 hours. Now, when you see it said the same trip, it's going to be an equal distance problem. So you want to draw the picture right away for the equal distance. My pen down here, I think I'll go with red. So the distances are going to be equal distance. This is distance Silver Arrow, distance Orange Blossom Special. They're both the same. They do not tell us the distance, but they tell us the time. So let's just get this set up. If the distances are the same, then you write the distance of the one equals the distance of the other. Right away, after you set up your equal distance, of course we did problems that were different than that this week. As soon as the one on the test is equal distance, once you set that up, you translate it. Distance always equals the rate, whoops, my pen stopped working. Hold on, my computer's thinking or something. Anyway, it's the rate, there we go, rate Silver Arrow time Silver Arrow equals rate Orange Blossom time Orange Blossom. Now we have four variables, so we talked about this in class. You're going to need 4 equations. So let's see what the problem will help us out with. It said the Orange Blossom Special made the trip in Silver Arrow made it in 20 hours. So we have the time of the Silver Arrow is 20. The time of the Orange Blossom is 8 hours. So they're giving us a lot of information. So now we have 1 equation, 2 equations, 3 equations. We only need 1 more equation. And it said that the Orange Blossom made the same trip in only 8 hours because its speed was 60 miles per hour greater than the speed of the Silver Arrow. So we would say rate of Orange Blossom equals rate of Silver Arrow plus 60. Now we have our 1 equation, 2 equations, 3 equations, 4 equations. So once we have our equations, we're going to put everything into, this is like our master equation. So everybody goes into the master equation. So we're going to leave the rate of the Silver Arrow in. We have the time of the Silver Arrow is 20. So we'll put 20. You have to leave 1 variable in. You can't substitute all of them. Rate of Silver Arrow equals, okay, we have the time of Orange Blossom is 8. The rate of Orange Blossom is the rate of the Silver Arrow plus 60. And we're just going to solve that real quick. This is the easy part, right? Equals 8 rate of Silver Arrow plus 480. Subtract 8 from both sides, we have 12. R sub S equals 480. And we get the rate of the Silver Arrow is 40. And it's miles per hour, but that's not what they're asking. They're asking for the distance. So you go back up here. Distance equals rate times time of Silver Arrow. So the distance, which would be the same because they're equal distances, equals rate, which is 40, times the time of the Silver Arrow, which is 20. And you're going to get 800, and it's a distance, so the answer's in miles. So hopefully you didn't have any trouble in that one. We did it in class, but distance problems are always a little tricky. Okay, let's move on to our coin problems. So we have some quarters and half dollars. The total coins are 200. The total value is 75. Now some of you do this in your head, and it could work unless the problems get really tricky. Now, just remember, you need a number equation with just how many coins there are, and then you need a value equation. We always do our number one first. We have some quarters, n sub q, and we have some half dollars, n sub h or half dollars. And the total number of coins is 200. If I just counted the coins on the table, there would be 200. It has nothing to do with how much a quarter is worth or how much a half a dollar is worth. The next one is our value equation. That one cares about how much they're worth. So quarters are worth 25, and we move over our decimal point so we don't have decimals. Half dollars are worth 50 cents. And that equals $75. Since we moved our, instead of saying 0.25 for quarters that we moved it over to, we have to move this decimal over to as well, and we get 7,500. Now we have a simple elimination problem. I'm going to take and multiply the top row by negative 25. So I'm going to get negative 25 number of quarters minus 25 number of half dollars. And if I take negative 25 times 200, I'm going to get, I need my calculator here, I'm afraid. Hold on a second, sorry about that. Can't think very well and do these problems. So 25, I could do this in my head, that's silly, times 200 is 5,000, so this will be 5,000. And it's negative. And then I'm just going to add them up. So these cross out. We get 25 number of half dollars equals 2,500. Number of half dollars equals 100. And the number of quarters equals 100. You guys probably could have done this in your head, but I don't know on the test if it's going to be this simple. Okay, number 27, lesson 27, number 3, problem number 3. There were 6 more girls than twice the number of boys. So the number of girls equals twice the number of boys plus 6. And the number of girls plus the number of boys equals 36. 6 more girls than twice the number of boys. So the girls are 6 more than twice the number of girls. And then we're just going to do some simple substitution. This is going to go in where NG is. So NG equals this, so I can replace NG with this. So 2 times the number of boys plus 6 plus the number of boys equals 36. 3 number of boys, combining these two, subtracting a 6 from both sides, I get 30. Number of boys equals 10, so that tells me that the number of girls is going to be what's left, which would be 26. Alright, once you get these equations set up properly, this guy right here is kind of tricky. Alright, percentage problems. So, we have, this is number 4, it's lesson 26, number 4, 14% of all the kids. When they say 14%, it means of everyone. Maybe these aren't kids, I guess they're the total. 14% of the total were belligerent. The rest were eristic. I had to look that up. Eristic means enjoys controversy. So they're not really, belligerent's kind of mean, the way mean-spirited. But eristic is just they enjoy the controversy. It might not be a mean spirit. Okay, so 43% were eristic. How many were belligerent? So 14% of the total. So 14% of all the people. So total is all the people were belligerent. We don't know how many out of how many were belligerent. We don't know how many were belligerent there. so we don't know that one. But we do know that there were 4,300 aristic. So if there were 14% were belligerent, that means that there were 86% that were, out of the total, that were, these are the belligerents, and these are the aristic. 86% of the total were aristic, and we know how many aristics there were. There's 4,300. So that's our equation. 86% of the total were, see the tricky part in here is they give you the belligerent, but over here they give you the number of aristic. So you divide both sides by 0.86, and you get let's see, you get 5,000. So the total number of people were 5,000. Now to go back to answer the question, how many were belligerent? Well, 14% of the total were belligerent. So 0.14 times the total, 5,000, is going to give us our belligerent. And so that ends up being 700 were belligerent. Oops, spell it right. Belligerent. Okay, that's it for the first 4 questions. I have to go get another sheet of paper. 1 second. Paste in a sheet. And this is study sheet number 2. Alright, now we're done with word problems. Let's move on to problems with variables and numbers. So we're going to divide. Alright, divide, and we're going to divide x cubed minus 2 by x minus 5. Keep in mind we have to include placeholders. So we have x cubed. We don't have any x squared, so I'm going to put a placeholder in. We don't have any x's, so I'm going to put a placeholder in. And then we have minus 2. Some of you still have trouble with long division, so I'm going to go fairly slow on this. You got this one right, just skip on through it. So we get what times x gives us x cubed? Well, x squared times x, of course, gives us x cubed. You want to put up here what you can take times the first term in the binomial to give you the first term in the dividend. So you take it times that one. Once you determine it, you take it times that one, and then you take it times the second term in your binomial. So we're going to get minus 5x squared. The way I taught it last year, and I still do from the time I took Algebra 1, I guess, was you change the signs and add. So you get 5x squared, and then you bring down the next term. And you start the process all over again. What times x gives us 5x squared? Has to match exactly. Well, 5x times x gives us 5x squared. 5x times negative 5, then you take it times the first term, and then you take it times the second term, so you get negative 25x. Change your sign and add. You get 25x minus 2, and you start the process all over. What times x gives us 25x? Well, it's 25. So you get 25x. 25 times negative 5 is negative 125. Don't forget to change the signs and add. So you get 123. That's your remainder. So you add your remainder at the top, 123 over the divisor, x minus 5. Dividend, divisor, quotient. Okay, onward into our favorites, radicals. So, did I skip a problem? No. Okay. Alright, let's do some radicals. We are to simplify these radicals. First thing you have to do is simplify. If the radicals can be simplified, you need to simplify it. This would be, what we're looking for is the biggest perfect square that divides in the square root of 18. You can do the tree, which I feel like you're mostly comfortable with, or you can do this more mature method. What's the biggest perfect square that divides into 18? Well, does 4 divide into 18? No. Does 9 divide into 18? Yes. The next one would be 16. That's too big. So it would be square root of 9, square root of 2. 18 is 9 times 2. Okay, let's move on. Biggest perfect square that divides into 8. I would guess the first one would be 4, and what's left? 2. 4 times 2 gives you 8. I'm just putting the perfect square first. If you want to do a tree, it would look like this. 18 would be 9 times 2, and then 3 times 3. And so here's our pair. The 3 will eventually come out. That's what we're going to have here. Let's just finish this last one. Negative 3, square root of 25 times the square root of 2. That's the biggest perfect square. 4 doesn't divide into it. 9 doesn't divide into it evenly. 16 doesn't divide into it evenly. So I hit 25 and it works. So square root of 9 is 3. That's where you would have got this 3 right here. Square root of 2. Plus 5 times 2 square root of 2. That's the times sign. Oops, I just erased that. And then here we have 3 times 5 square root of 2. And that gives us 18 square root of 2 plus 10 square root of 2 minus 15 square root of 2. Isn't it handy that they all are square roots of 2? So we just take those and we add 18 plus 10 minus 15, and our final answer to this problem is going to be 13 square root of 2. That one is on your paper. Okay, number 7. Okay, this one we're going to distribute before we do anything. So remember, you multiply the numbers in front first. So I'm going to get 6 square root of 75 minus 4, and remember, this would be square root of 25. Or you can say, anytime you take the square root of a number times itself, you just get the number. So you can do a tree for 75, or you can say what's the biggest perfect square that divides into 75. So you do start with 4, 9, 16, finally we hit 25. 25 times what gives you 75? It would be 3. 4 square root of 25 is 5. So we get 6 times 5 square root of 3 minus 20. So your final answer is 30 square root of 3 minus 20. And I'm wondering if I lost some of my paper here. It doesn't go down any further. So hold on, let's get the next page. We're starting with 8. Whoops, I did lose a couple. Okay, let me just try something else. Hold on a second. Paste. It doesn't seem to want to give me any more of that one. Okay, I'll come back to that. Let's just go on the next study sheet. Alright, so we have to come back to number 8. I don't know why it's not giving me 8. Okay, this is the whole thing. Okay, we're jumping to number 10. We're to add this, and what that means is we're going to find a common denominator. There's no equal sign in this problem. It's an expression, so you can't get rid of your denominator. You have to find a common denominator. If you look, the common denominator, this would be over 1. The common denominator would be m squared p. So you say, what is missing from this one that this one has? It has everything. So you can just copy the numerator down. This one is missing everything, so you need to multiply the top and the bottom by m squared p. So this is going to be minus c m squared p. And this guy, he's missing an m, so we get m squared, and a p, so we have to do the top and bottom by that. So it's going to be 2mp. And that's your final answer for that. Okay, next one's kind of tough. It's solved by graphing. I'm going to really do a rough sketch of this. It's not going to be, if you do these graphing ones, you should really do graph paper if you have it. So it says solve by graphing and then check by elimination or substitution. So the first thing you have to do is put this in y equals mx plus b form. So I'm going to get minus 2y equals negative 3x plus 10, and I still don't have it, the y by itself yet, so you have to divide by negative 2, so it's 3 halves. I changed my variable around, didn't I, there? Alright, hold on. I'll just erase that and put the right variable. Okay, there we go. Then it would be minus 5. So you go over here to your graph, you graph that one. Your y-intercept is negative 5, so 1, 2, 3, 4, 5. And let's just put a couple lines on here. Now mine's not going to be very accurate because I'm not using graph paper. So I could have put this on if I was really being careful. Okay, so you're going to put a point on, this is your y-intercept, b is what you do first, put a point on negative 5. Your slope is positive, I'm going to go up 3, 1, 2, 3, over 2. And then I take a straight line and I connect those. Isn't too bad. And then I'm going to graph this next one, y equals negative 1/2. So that's just a straight line, horizontal line, I should say, across 1/2. Like that. And the intersection is the point where they intersect. And that's the solution to the problem. So this point you have to try to identify by graphing. So our x value looks to me like 3. And the y value, it already says all the y values are negative 1/2, so it's negative 1/2 is your y value. I think, despite my bad graph, I think I hit it right on. So let's give this, we want to substitute to see if it works. So I'm going to take this negative 1/2 and put it where the y is. So we get 3x minus 2 times negative 1/2 equals 10. 3x, this is going to be a plus 1, equals, if I subtract 1 from both sides, I'm going to get 9. Divide by 3, x equals 3. And we already have that y equals negative 1/2. So that is a good graph. Okay, now for the toughest kind of problems that you face are these where it says, lesson 25, number 20, you have a point and you want to find a equation of a line that goes through this point and is parallel to this line. So we've done these many, many, many times, so hopefully this will be the time that you get it. Points are always x, y, right? And this is m. If it's parallel to this line, it's going to have the same slope. But if it's going through this point, it's going to cross the y-axis somewhere different than negative 2. So you get out your friend, y equals mx plus b, and you just simply plug in everything but b. So y is 5, m is 1/6, x is 3, and we don't know Mr. B. And this crosses out, so this is all equal to 2. So you get b equals, if I subtract 2 from 5, I get b equals 3. I did something wrong here. Hold on 1 second. B equals 1/2. Okay. Hold on a second. Okay, so this would have been 1/2. So if you subtract 1/2 from, this would be 10 halves, right? 5 is equal to 10 halves. So we would get 9 halves equals b. And this didn't seem right about 3 for the answer to that. And then you just put it back in your equation. y equals m, if it's going to be parallel to this line, it's going to have the same slope, x, but it's going to have a different y-intercept. The y-intercept is 9/2. And that's it for 25. This is really, as long as they give you the slope, they're really easy, because you just put it right into that formula. Okay, 13. Okay, you guys hate these problems, but they're not hard. You have to find x, y, and p. Just remember, these are parallel lines, bad as mine look, and they're cut by transversals. If parallel lines are cut by transversals, its segments are proportional. So 7/9 equals 11/p. And you just cross multiply, so you get 7p equals 99, p equals 99/7. That's the easy part. Alright, that's part 1. Part 2 is you need to work with these angles. So, we know that this angle is equal to this angle because they're on the same side of the transversal and they're above the parallel line. They're corresponding angles. So I could really write this one right here, 3x plus 2y. Now we know that if they're both inside the parallel lines on the same side of transversals, that these add up to 180 degrees. So I'm going to take 6x minus 2y plus 3x plus 2y and say they're equal to 180. The two y's cancel each other out, so we get 9x equals 180, and we're going to find out that x equals 20. We also know that these two have to add up to 180. I mean, you could just substitute it back, well, let's just do it that way. So we know that 6x, which would be 20, right? 6 times 20 would be 120. Let's just write this out. 6x minus 2y plus 80 equals 180. These two, they lie on the same line. They're a linear pair. So they add up to 180. So we would get 6x minus 2y equals 100. And we know that x equals 20. So if we put the 20 in here, 6 times 20 is 120, minus 2y equals 100, minus 2y equals negative 20, and we get y equals 10. And I think that's right. So that is, and we also know that 3x plus 2y equals 80 because they're corresponding angles. So if we put it in there, 3 times 20 would be 60, plus 2 times 10 would be 20, and 60 plus 20 does in fact equal 80. Okay, next sheet. Told you these were long. Okay, page from. We'll still have to do 8 and 9 yet. Okay, number 14. Okay, you have to find A, B, and C for this one. These are rather long. So, you can find A using the Pythagorean theorem. 7 squared plus 4 squared equals A squared. 49 plus 16 equals A squared. 65 equals A squared. A equals the square root of 65. So this is the square root of 65, and this is the square root of 65 plus B. Now these are similar triangles. I'm going to separate them out. I'm separating these out into the smaller triangle and then the larger triangle. They're similar triangles because they both have a right angle and they share this angle. So they're similar, their angles are all the same. So we can do proportions. So we can say 7 over 12, this is to this as 4 is to C. And we just cross multiply, we get 7C equals 48. C equals 48 over 7. The hardest part here is with our radicals. So we're going to do the same thing. The sides are proportional, so we make proportions. 7 is to 12 as the square root of 65 is to the square root of 65 plus b. We need to cross multiply. The whole goal is to get b by itself. So we're going to get 7 square root of 65 plus 7b equals 12 square root of 65. And if I subtract 7 from 12, I'm going to get 7b equals 5 square root of 65. Divide both sides by 7. b equals 5 square root of 65. My hand is getting kind of tired right now. It's getting sloppy. So you get b equals 5 square root of 65 over 7. So here's our b, here's our c, here's our a. First one you're going to use Pythagorean theorem. The next ones you're going to do, you make your sides proportional. Okay, I might have that short sheet thing again. Okay, 15. Solve this. Now you have a fractional equation, so that means you can multiply everything by a common denominator and eliminate your fraction. So 5, you would take 5 goes into 10 2 times, and then we would distribute the 2. So we're going to get 8x minus 16, because we would take this times 10, we're taking all this times 2 now. Okay, we have that, plus 2 goes into 10 5 times, so we're going to take this one times 5. So we're going to get 10x minus 20. And don't forget to take it times the 9. That's an easy thing to forget. So we're going to get 18x. And if you would have had a negative sign here, you would have needed to distribute it through both terms in the binomial. So where are we? So we get 18x minus 36 equals 90. 18x. Hold on 1 second, I'll make sure I don't miss anything. I'm hoping that my battery doesn't go dead on my computer. Okay, we get 18x equals 126. And finally we get x equals 7, which is the solution to that one. And again, it's not letting me have that whole sheet. So hold on, I'm going to go try to find the rest of the problems. So that was number 15. So I need to get 16. Hold on. New. Just start over. Open. Okay, let's see if this one works now. There we go. 16. So we're going to get negative, and we're going to work inside the parentheses. This would be negative 10 times negative 4 times negative 2 equals 2 to the 0 power be negative 1 times x minus 4. Alright, just a little afraid my battery's going to be dead and I'll resolve this. So, hold on. So we're going to get 40 minus 2 equals negative x plus 4. That's going to give us negative 38 equals negative x plus 4. And if I subtract 4 from both sides, I get negative 42 equals negative x, and we finally get x equals 42. Okay, I need to text one of my kids to bring me my cord, so hold on. Okay, sorry about the delay here. Okay, let's do 17. What we have to do again is solve this. We're going to do the same thing. Oops, we just lost it. I'm glad we'll just stay doing this for you guys. Plug this in for me. Yeah. So we're going to lose everything. Okay, all is good. Okay, let's go on to this next one. The same thing, find the common denominator, which is going to be 4, multiply everything by 4. So this one, 2 goes into 4 2 times, so it's going to leave us with a 2. So 2 times 5x is 10x, 2 times 3 is 6, minus 4 goes into 4 1 time, so it's just going to be 3. 2 goes into 4 2 times, 2 times 5 is 10. So we get 10x plus 3 equals 10. 10x equals 7. X equals 7/10. Alright, let's go back and get those two that we missed. Number 8. And I think that was from the one I saved as 2. Okay, here we go. Number 8, this one is simplify. So it'll say simplify. So you need to find out what you can take out of it. So I'm going to take out a 4x cubed out of the top. So we get 2x squared plus 3. And on the bottom we have a 4x cubed. These cross out, so your final answer, we did this in the whiteboard, is 2x squared plus 3. Okay, scientific notation, we didn't really get this done in class. We tried to, but we were rushing. Scientific notation, what you want to do is put each of these numbers in scientific notation. So what that means is I'm going to move my decimal point over 1, 2, 3, 4. This one went to the left, 4, so you're going to add 4. When you go to the left with scientific notation, you add that many to your power of 10. So this is going to be 3.8 times 10 to the 7th. This one we have to move it to the left 1, 2. So we're moving it to the left, so it's going to be plus 2. So I'm going to add 2 to the negative 4. So we get 3.0 times 10 to the negative 2. And then in the denominator, I'm moving it to the right. 1, 2, 3, 4. 1, 2, 3, 4. So I'm moving it to the right, so I'm going to subtract 4. So I'm subtracting 4 from that, and I get 10, 1.9 times 10 to the negative 14. I mean negative 9. Can't read my writing. Okay. Scientific notation means you put the decimal point between the first two non-zero numbers. So that's how we get that set up. Once we get it set up, then we just have to simplify. So I just know that 1.9 goes into 19 goes into 38 2 times, so 1.9 goes into 3.8 2 times. I'm going to multiply 2 times 3, so I'm going to get 6.0 times 10. I'm going to bring this up to the 9th times 10 to the 7th times 10 squared. I just moved this one up because we would have subtracted it anyway. By subtracting it, we're going to end up making positive. So our final answer is 6.0 times 10, and if we add up all our exponents, we are going to get 9 plus 9. I think I copied one of these wrong. Let's see. This should be a negative 2. So it's going to be to the 14th power. And that's how you do those. Alright, let's move to the last sheet. Here we go. Number 18. These are the fast ones anyway. This one's just to remove the common monomial factor. So we're going to look, there's an A in all of these, right? So I can take out an A. Is there a B in all of them? Yes, I can take out a B. And that's it. So let's copy what we have left. We have negative 2 plus x plus x squared. We should put this in order to see if we can continue to factor it. Put it in descending order of variable, like this. And I think it might be factorable. So you factor it, you keep going with these. X times x, 2, 1. You want the bigger one to be positive, the smaller one to be negative, because you end up with positive, and that's your final answer to that. 13 and 15 are the same thing. You can take out an AX on all of these. So I'm going to get 24 minus 5x minus x squared. These are all the same. So you get AX. Oops, I should have taken out a negative, because when I go to rearrange this, I'm going to have a negative in front, which we don't want. So I'm going to take out a negative instead. And when you take out a negative, it makes all your signs change. So I'm going to get x squared plus 5x minus 24. We factor it using reverse FOIL. So we're going to get x and x. What times what gives me 24, and when I subtract it I get 5. Should be 8 and 3. Positive and negative. Okay, same idea. This time we can take out a p. So we get 56 minus 15x plus x squared. Put it in descending order of variables. X squared minus 15x plus 56. Signs are both going to be the same because it's positive. They're both going to be negative. So we factor them. X, 8, 7. 8 times 7 gives you 56. And when you add them, you get negative 15. Okay, last problem. I don't know how long this video is going to be. Okay, here we go. We're going to plug these in. I'm just going to start writing it. Negative 3 to the 0 power. This 0 power is only on the 3, not in the negative, so it's just going to be negative 1. Then we get negative 3 minus 4. This squared is only on the 2, not in the negative, so it's going to stay negative here. Minus 4 times negative 2, I'm going to plug in. A is negative 2, x is 4, a is negative 2. I like to use the parentheses when you're putting in your numbers. Okay, start from the left again. Negative 1 times negative 7 is negative. Now we're having 1, 2, 3 negatives. So when I multiply all these numbers together, it's going to end up being negative. So really I have, let's just put in an extra step. 4 times negative 2 is negative 8. Negative 2 times 4 is again negative 8. Negative, negative 2, which means the opposite of negative 2 would be plus 2. Okay, left to right. Negative 1 times negative 7 is 7. Negative 8 times negative 8 is 64, plus 2. And hopefully we end up with the right answer here. See if I have the answer somewhere. And now I do. Yes, we're going to get the right answer if you add it from left to right, or you add 7 and 2 and get 9. 9 from 64, negative 64, you're going to get negative 55. So hopefully endure that whole video. I barely made it, but hopefully it's helpful to you in doing well on your test. Please watch this. Please try to learn from it and rewatch it if you need to. Alright, that is it for the study review.